Now we're going to start looking at the shapes of the sine and the cosine graphs on your standard x and y axis plot. But before we start drawing them on our own, I want us to look at some of the shapes and identify a few of the important characteristics of them. This wavy shape that you see on the plot is the basic image of both the sine and the cosine function. And two of the terms you'll often hear in the context of sine and cosine graphs are the amplitude and the period. So you can see that there are three important heights to a sine and a cosine graph. The ones at the various highest points we call the maximums. Then there's the point that's kind of passing through the middle. And then at the very bottom of the graph, we have what we call the minimum, the lowest that the graph ever hits. The amplitude is going to define the distance from the middle of the height up to the top, or from the middle down to the bottom. So basically from the highest to the lowest point of the graph, from the maximum to the minimum, is twice the amplitude. So if that number is 4, it goes 4 up and 4 down. The other important number is the period. And the period defines how long it takes for the graph horizontally for it to complete one full cycle or one full image of the pattern. Now, one of the nice things about the period is it doesn't actually matter where you start measuring it from. One of the easiest ways to do it is to pick the maximum and then just kind of trace along how long does it take for your graph to get back to that very highest point. So whatever this horizontal length is, that's what we call the period. Do be aware though that this can be measured from any point along the curve. One of the most common ways to do it is to pick the point that's passing through the middle. And then the only thing you have to be careful about is you don't stop when you get back to that middle height, because I have to keep in mind that this is where the graph was increasing. So since it's decreasing on this part, I need to keep going until I hit that middle height again here, and I'm going in the same direction, the increasing direction. So this piece would represent one full period of the graph or one full cycle of the pattern. So for a quick example of identifying those numbers based on a graph with actual numbers plugged in, let's start with the amplitude of the graph. Now, if you look at the very highest point and all the way down to the lowest point, I can see that the distance from 4 to -4 would be a length of 8. So you can either cut that whole length in half, or you could identify where the middle height of the graph is, and then just measure that distance from that height up to the top, or from that height down to the bottom. So from 0 to 4 is a length of 4. For the period, we just want to measure a horizontal distance. So try to pick a point that's easy to measure from, like the top to top or bottom to bottom, or I often like to use from the middle of the graph. So this scale, it would be nice if it had more tick marks marked off, because since this is pi over 2, I know that halfway between would be pi over 4. It would be half of that. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, etc. And the same thing could go in this direction. So if I've identified that the length between tick marks is pi over 4, the easiest thing to do would be to pick a point where the graph is easily measurable. So here it is decreasing and touching the x-axis. And then measure how far it is horizontally till you hit that same information happening again, so decreasing and passing through the x-axis here. So if I count this off, that's 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4. So this would be 6 of those pi over 4 pieces. And then if you reduce that fraction, this would be equal to 3 pi over 2. And your period will usually be a number that has a pi in it. Don't forget that the number pi does have a decimal value. So this can be measured as approximately 9 over 2, but most of your scales dealing with sine and cosine graphs will have pi numbers for the x measurements anyways. So now let's talk about identifying some of that information algebraically. Whether it's a sine or cosine graph, we call these sinusoids because they both resemble the sine graph. They basically look the exact same, and we'll look at that in more detail later. But there are 4 important numbers in either the sine or the cosine setups, and we use the variables a, b, c, and d to represent those. So no matter which function you have, our rules are the same. The number out front, a, if you take the absolute value of that, that will give you the amplitude, which we just saw graphically means the height of the waves. If you take the absolute value of the number here that's being multiplied by x, they may or may not use parentheses, because if there isn't a number being added in the C spot, then the parentheses aren't necessary. But make sure you pay attention to numbers multiplied by x, that's b. Take the absolute value of it and do 2 pi divided by that number, and that'll be the horizontal length for your graph to complete one full cycle, which again we just looked at graphically. The phase shift, which is also sometimes called a horizontal shift, comes from both the C and the B values combined. Now, usually you only have a number in the C spot, and that makes it easier, because if you don't see a number being multiplied by x, then that means B is 1, so you can just ignore that part of the fraction. But if you do have both, take this number, divide it by B, and change the sign. Now, what's confusing about those is that the signs kind of flip, because if you have a plus number, that means it's actually going to be moving to the left, and if you have a minus number in the function, it'll actually be moving to the right, and that's what the negative sign is taking care of here. So sometimes you'll need to indicate the direction by showing the positive or negative sign, or many times I just kind of write whatever the number is that you get from doing C divided by B, and then I indicate whether it's going to be going to the left or to the right. And then the last number is the vertical shift, and that just comes from the value here, D. And there's no weird flipping, anything happening with that number. So if you see a plus number, it's going up. If you have a negative number, it's going down. So the only ones that kind of go backwards from what you expect are the ones inside of the parentheses, the B and C values, and we'll see that in action on some examples. So especially in the beginning, I'm going to show what the A, B, C, and D values are to make it a little bit easier to fill in the 4 requested pieces of information. So remember, A is the number being multiplied out front of the sine or cosine function. In this case, the number is 1/2, and it's already positive, so the absolute value is not changing anything here. But my A value is 1/2. B is the number that's being multiplied by x. I don't see a number in this case, which means that B is equal to 1. C is the number that's being added, and for the C value, there have to be parentheses used to add or subtract something to the x value specifically. So if you don't see parentheses with something being added, then C must be equal to 0. And then if there is a number being added or subtracted, but there are not parentheses, then that number has to be D. So now that I have these 4 numbers identified, if you look back at what was on the previous slide, we can just fill in the rules for all 4 of these. Starting with the amplitude, I said it's the absolute value of A. So since this number is already positive, my amplitude is 1/2, stays positive. The period is going to be 2 pi divided by B. But since my B value is 1, I can actually just ignore the 1 and say that my period is 2 pi. You don't need to write a number divided by 1. The phase shift comes from C divided by B, but if you don't have a C number, then you don't even have to worry about phase shift. There is none. And then the vertical shift is just whatever the D value is. Since it's a -2, you either need to indicate -2, or I would want you to say that it's going down 2. To specify the direction with an arrow, or even by writing out the word down, that would be fine. So graphically, once we learn what the basic shape of the sine of x graph looks like, we'll now be able to say that this sine graph has waves of height 1/2. It will take a length of horizontally 2 pi for the graph to repeat itself. We will not be shifting the graph at all to the left or to the right, but we will be moving the points on the graph for the normal sine function down 2 units. So if it was at a height of 0, it will move down to -2. And that's what we'll be looking at in the next section. Here's another example asking us for those 4 components, and this time we do have numbers in all 4 spots. So to begin, the number being multiplied by sine or cosine, that's your A value. The number being multiplied by x, specifically to the x variable, is 2, so that's B. The number that's being added or subtracted that is in parentheses, and usually this number will have a pi in it. That's pretty common. That number in this case is pi. And then the number that's being added or subtracted outside of the parentheses is your D value. So if we're filling in our 4 components again, the amplitude is the absolute value of A, but this number is always positive, or it's already positive, so keep it as +3. The period is going to be 2 pi divided by the absolute value of B, but again, that number is positive, so I can ignore the absolute value bars. And I do want to reduce this fraction whenever that happens. So 2 pi over 2 is equal to pi. The phase shift on this question is going to be negative C divided by B. So negative C over B, or since this number came out to a negative, I would also accept it if you said that this one is going to the left, pi over 2. This one can be confusing because the fact that I have a positive here, the graph is actually going to be moving to the left, which is easy to identify if you notice that the formula is negative C over B. That's what causes that sign flip. And then the last one is the vertical shift. You don't have to do anything for this number. It's just whatever D is. The fact that that was a positive means it's going up, so the positive indicates that, or you could just draw an arrow or write up 1 unit. So this graph, once we learn how to draw the sketch of sine, it's going to have waves with a height of 3. So it'll go up 3 and then down 3 from the middle of the graph. It'll take a horizontal length of pi for us to see the full wave pattern. This graph has the points for the regular sine function being shifted to the left pi over 2. And for the y-coordinates, all of the y-coordinates on the sine function are going to be moved up 1. So this will be very useful information for sketching our graphs in the next bit of notes. That's all for this one. Thank you.